What has been CriticalSoftware's involvement for the Square Kilometre Array facility?
The Square Kilometre Array facility intends to listen to the dawn of the universe, basically to discover the unknown. It will be the largest science facility ever built by mankind, so it will push the technology to its limits. There will actually be no larger big data system. CriticalSoftware has been involved in 3 subsystems of this facility. The telescope manager, where we have done independent requirements analysis and reliability, availability, maintainability and safety plan and the actual assessment throughout the design phase. The science data processor, where we have developed a slow transient pipeline prototyping for scientific data processing to improve the processing, the memory usage and the execution time, and the signal and data transport system, where Critical has done an independent analysis on the system requirements and also the reliability, availability, maintainability and safety plan that contribute to improve the system requirements.
What has CriticalSoftware done in the telescope manager system?
The telescope manager system is the core of the SKA system because it controls the full life cycle of the system from the scientists' requests to make observations on the sky, on the universe, and it will also control the telescope directions and diagnostics and safety controls. What we have done here is we have simply done an analysis on the requirements to make an improvement and the completion of the requirements of the telescope manager. And later on, we have provided reliability, availability, maintainability and safety of both the software and the hardware, including the integrated logistics support, both at subsystem level and at this SKA level, so the SKA office level.
What has CriticalSoftware done in the science data processor?
The science data processor is the computing hardware platforms, software and algorithms that are needed to process the science data from the correlator and non-imaging processor into the science data products used by the scientists. We have been working together with the University of Manchester since 2015 in the slow transients pipelines. These slow transients pipelines usually take hours, days or weeks. Obviously slow is a bit misleading because those samples need to be processed really fast, usually under 1 second. So we have developed these slow transients pipelines prototyping. We have used HPC experience that we had from the past, and we have reduced the execution time and the memory usage for these large scientific data processing. The achievement was an improvement of at least 50 times in processing time and memory usage compared to the initial baseline.
What is the relevance of the work performed in the SKA to the work CriticalSoftware does in other industries?
The SKA will be an excellent technical challenge because this will be the largest IT project ever. It's a challenge with unprecedented scale, so it's extremely important. The knowledge acquired and the fact that we will be working with experts and engineers from over 20 countries will be also extremely valuable. There will be technology that has never been developed before, and we have to increase the computing processing power in about 100 times of what we have in the last years. The potential reuse of knowledge and technology is extremely large. We can use the process optimization for all kinds of large industries. For example, manufacturing optimizations, image processing for quality control in high sensitive industries such as semiconductor industries, or for satellite data coming from Earth observation satellites, for example. We can also improve the medical and biology areas by increasing the human DNA sequencer properties and algorithms. The high processing computing can increase the speed of processing and detecting, for example, diseases and other situations. We can also reuse the knowledge or use it together with transportation railway area, for example, for station monitoring, for aircraft safety control, in order to detect in real time dangerous situations and act upon them. And basically every system that will produce large amounts of data, we can process, take actions and act upon.